Dear students, in the previous video, that is in the third video, we did the solved example 5.9 up to acceleration. Still we have to find tension in the string, and actually here one is acceleration is asked, and second is tension in the string is asked, and third one let us add another also, because exactly this model problem is given at the end of the lesson as 11th problem. Let us see that. This 11th problem is just like 5.9. So in this, first calculate the initial acceleration, B, the tension in the string, C, the distance the block would continue to move if after 2 seconds of motion the string should break. So in that problem, in the solved example, only A and B are there. Let us include this C also, and here instead of 2 seconds, let us take 3 seconds. So in the previous video, we have added the two equations. Plus t minus t cancel. Here 22 is equal to 23a, or a is equal to 22 by 23 meter per second square. So this is first answer. Now to find t value, we can substitute a value in either of the two equations. Let us take second equation. So we get this is the second answer. So next, let us add one more thing, and that is the distance the block would continue to move if after 3 seconds of motion, the string should break. Let us take the diagram. So here the large mass and small mass are connected by a string, and now suppose both blocks are at rest. At t is equal to 0. That is, you are holding the blocks. Now you released the blocks, and allowed them to move for 3 seconds. So initially, now let us consider large mass Initially you were holding the blocks, therefore the initial velocity was 0. You allowed them to move for 3 seconds of time, and after 3 seconds the velocity gained by this mass is how much? V is equal to U plus AT, kinematic equation. A value you got 22 by 23 into 3 seconds, 66 by 23 meter per second. Now the string is cut. Beside mass M. Now what happens? There will be no pulling force. Since it is cut, there will be no pulling force. Here its velocity was 0, and here the velocity is 66 by 23 meter per second. So here the string is cut. So now this velocity becomes initial velocity, and since the string is cut, there is no pulling force. So after cutting string, initial velocity final velocity. See here, there is no pulling force, only frictional force. As the block is moving to right hand side, frictional force works in the opposite direction. So here, even though it is cut due to inertia of motion, already this is in motion. So even though when the string is cut, there is no pulling force, but due to inertia of motion, this block will tend to move. Since it is moving to right hand side, to left hand side, the kinetic friction will be there. Since this friction always tries to stop the block, so this can be taken as stopping force. So this frictional force stops the block after some time. So in that way, the final velocity becomes 0, and the distance traveled, yes. So the equation connecting these is to AS. So the distance R, S is equal to 1 by 2A into V square minus U square. Here U is there available and V is available, but A, here A is, see here, once the string is cut, its velocity gradually decreases and comes to rest. Why its velocity is decreasing? Because of frictional force. There is no pulling force, only frictional force is there, and frictional force tries to stop the block, therefore its velocity gradually decreases. Okay. Uh, so this its velocity is decreasing means it is decelerated. But its deceleration we don't know. It's A means here where A is deceleration. This we need this. So for that, what shall we do here? Here the force working on the block, the force stopping the block is, here let me write. Stopping force is here kinetic friction. So stopping force, here its mass is capital M. So M A is equal to, this is by Newton's second law, F is equal to ma, and here kinetic friction is Fk. Here stopping force is nothing but kinetic friction, therefore here stopping force is kinetic friction, therefore ma is equal to Fk. But by the law of kinetic friction, Fk is equal to mu kn, and here downward is gravitational force, upward is normal reaction. So N is equal to mg. So here we write, capital M here, M gets cancelled, A is equal to mu kg. But here this is deceleration, and a deceleration is shown by negative sign. If this is equation 1, if this is equation 2, in place of A, let us substitute this value. So substitute this in 1. S is equal to 1 by 2 into minus mu kg into v square minus u square. Substituting the values, see here mu k value is 0.04, g value 10, v square final velocity is 0 minus initial velocity is so in this way, see here minus sign is there, here minus sign, here minus gets cancelled, so we get the answer in meters. Now our next topic is short answer question 8. Why is pulling the lawn roller preferred to pushing it? First, let us consider pulling case. Let us take the wheel. The wheel of the lawn roller is on floor. Suppose this is pulling force. The pulling force is making an angle theta with horizontal axis. Now, if its mass is m, the gravitational force on it is mg, and normal reaction n. Now let us resolve the pulling force into, let us resolve this vector into two perpendicular components. Since this is theta, this component will be f cos theta, and this component will be f sin theta. So now this is removed. Now, in vertical direction, upward in vertical direction, A is equal to 0. It means the lawn roller is neither flying up nor sinking down. Sum of upward forces is equal to sum of downward forces. Here A is equal to 0 means net force is 0. When net force working on the roller is 0, then we can write sum of upward forces is equal to sum of downward forces. Upward forces are f sin theta n. Downward force is mg, or n is equal to mg minus f sin theta. But here, when you are pulling the roller is moving to right hand side, and the rolling friction will be in opposite direction, Fr. By law of rolling friction, Fr is equal to mu r n. Mu r into this n value. So this is the expression for friction. Now let us consider pushing case. This is the pushing force. This pushing force is making angle theta. This is floor. Gravitational force, normal reaction. This force can be resolved into two perpendicular components. So, along x-axis one component, along y-axis another component. If this is F, this will be F cos theta and this will be F sin theta. And here, since the roller is moving to right hand side, friction will be to left hand side. Now, just like that, sum of upward forces, sum of downward forces. Upward forces are N. Downward forces are here F sin theta, here mg. And now Fr, by law of friction, Fr is equal to mu r N. Substituting N value here, you got expression for Fr. Here this is pulling case. This is for pushing case, in which case the rolling friction is less. Here it is plus. Here every term is same. Here minus is there, here plus is there. So definitely, since here plus is there, so in this case Fr will be more, and in this case Fr will be less. And if Fr is less, if friction is less, you can lawn roller can be easily moved. Since friction is less, it can be easily moved. Fr less, so easy to move, hence preferred. In the pulling case, Fr value is less compared to this. Here Fr value is less. Fr less, so easy to move, hence preferred. Now, let us consider 12th problem. This is 5 kg block. This is 10 kg block. This is floor and this is frictionless floor. That is F is equal to 0. Between floor and 10 kg there is no friction, smooth. But between the two blocks friction is there, and the mu value 0.4, coefficient of friction 0.4. So in this problem, so here on the lower block a force is applied, 30 newtons of force is applied. So what is asked here? Force of friction between two blocks is equal to how much? That is asked here. Now using free body diagrams, let us consider free body diagram 1. Let us consider the large block, 30 meters, 10 kg. Since 10 kg is moving to right hand side, naturally frictional force works in opposite direction. So under the action of two forces, this block is accelerated to right hand side with acceleration A, because frictional force is less, applied force is more, so there will be some net force to right hand. What is the net force to right hand side? 30 minus F. So this force is less. Suppose this is some 1 Newton and this is 30 Newtons. So in this direction net force will be 29 Newtons. So under 29 Newtons this block will be accelerated, and that acceleration is A. Now net force to right hand side is equal to 30 minus F. In the motion direction force is taken as positive. In opposite direction force is taken negative. And net force according to Newton's second law, F is equal to ma. Its mass is 10 kg. Now let us consider second free body diagram. Five kg. See here actually what is happening. On frictionless floor, large block is there, on that small block is there. This is being pulled. This is being pulled. Then what happens to this 5 kg? You imagine you are traveling in a bus. You are sitting in a bus. Suddenly he increased the speed by applying acceleration. When bus velocity increases, when it accelerates, we move backward, and that is called, what is that called? Inertia of rest. This 5 kg is at rest. This block is being moved. So that's why this is on this, because of inertia of rest, it wants to be at rest only. But this is on this block, and this block is moved, accelerated to right hand side. So then this 5 kg, on 5 kg, a pseudo force is applied to left hand side. Just like our experience, our bus is when our bus is suddenly accelerated to right hand side, all the passengers move backward. A pseudo force appears on the persons, so they move backward. Just like that, on 5 kg, a pseudo force works in opposite direction. And say this force is, see, this is block A and this is block B, and say the pseudo force on B is FB. Now if this moves to left hand side because of the pseudo force, frictional force works to right hand side. If the pseudo force works to left hand side, in opposite direction frictional force works. So now on 5 kg, what forces are working? In this direction frictional force, and in this direction FB. Now it is at rest, therefore suppose five kg block is at rest. See here, in the bus, when it is accelerated, we move in opposite direction, but we do not change our places. If friction opposes, here also the same thing. Here pseudo force is working on 5 kg in this direction. At the same time, friction force is working in opposite direction. So under the action of two opposite forces, the 5 kg block can be at rest. Possibility is there. Therefore, we are supposing that the 5 kg block is at rest. If the 5 kg block is at rest, then we can write Fp is equal to F. According to Newton's second law, F is equal to ma. So this is small mass, so small m, a is equal to here it is F. Mass, its mass is 5 kg. Yeah. So this is second equation. Now on this 5 kg mass, gravitational force is working and upward normal reaction is working. Now let us calculate F maximum by law of friction. F maximum is equal to mu n, and say mu into n. N is equal to mg. And here substituting the values, the mu value is given 0.4, 5 kg into 10, so we get 20 newtons. So the maximum friction is this much. So you remember that F is all less or equal to F maximum. F is less or equal to F maximum. F value depends upon the applied force. If there is no applied force, F is 0. If applied force increases, then friction also increases proportionately and reaches a maximum value. Okay, now let us substitute F value from second equation in the first equation. Substitute 2 in 1. 10A is equal to 30 minus, in place of F you write 5A, or 10A plus 5A is equal to 30. Second square. Now substituting this value in equation 2, F is equal to 5A. F is equal to 5A, 5 into 2, 10 meter per second square. So this is the answer. See here, once again we have to check whether F less or equal to F maximum. F value you got is 10, and F maximum 20 newtons. So this is the answer. Now let us consider advantages of friction. Number 1, safe walking on the floor is possible because of friction between the floor and the feet. Nails and screws are held in the walls or wooden surfaces due to friction. Friction helps the fingers to hold a drinking water tumbler or pen. Vehicles move on the roads without slipping due to friction, and they can be stopped due to friction. When you apply brakes, by say, let us take the example of bicycle. When you apply brake, that rubber um, applies frictional force on the rim and stops like that. Here, fifth one, the mechanical power transmission of belt drive is possible due to friction. See, you might have seen this when you go to the floor mill. There, one wheel is associated with motor, another wheel is associated with a grinder, and both are joined by a canvas belt. And when he switches on, the motor starts rotating, and because of friction between the surface and the belt, this rotates the grinder. So these are the advantages of friction. Now let us consider disadvantages. Friction results in the large amount of power loss in engines and hence brings down their efficiency. The wear and tear of the machines increases due to friction, reducing their life. Friction causes